Hello, class. This is the video for section 3.7. I'm going to divide it into two parts. And part one will be the video on, okay, the first part will be on video on the polynomial inequalities. And then the second part will be the rational inequalities. Okay. For the first part, that is the polynomial inequalities, solving them algebraically. We did part of that in class yesterday. But I'll remember to make the video complete, I'm going to start from the beginning. Okay, so to solve a polynomial inequalities, we go through the following steps. Step one, you move all terms to one side, and then you rewrite so that it follows the order of a polynomial. You factor, and then from the factors, you factor into what irreducible factors, and find the real zeros of the polynomial. And then from that, you get what we call the intervals. The intervals are the zeros from the polynomial. You make a table. Okay, you use test values for the intervals, for each of the intervals, and then test whether it satisfies the inequality. And then based on that, you determine the solutions of the inequality and check whether the endpoints of these intervals satisfy the inequality or not. Okay, this may happen if the inequality involves less than or equal to or greater than equal to. Okay, so the following steps. Now, an important consequences of the intermediate value theorem is that the values of a polynomial function p do not change sign between successive zeros. In other words, the values of p, that's a polynomial, between successive zeros are either all positive or all negative. Now, graphically, this means that between successive x-intercepts, which are also the same as the zeros, the graph of the polynomial p is entirely either above or below the x-axis. Okay, so we considered this example in class yesterday, that we are given the polynomial p of s, which is 4 times x minus 2 times x plus 1 times x minus 0.5, and then x times x plus 2. Okay, if you have the polynomial p, if you grab this, these are your zeros. From the zero from the factor x minus 2 is what is 2, which is this zero here. And then x plus 1 is, if you set it to 0, you get -1, which is this 0 there, the intercept, and then half is for this one, and then -2 is that one. So we have this polynomial has a degree of 4, and that is why it has 4 zeros, 4 real zeros. So therefore, if you want to solve the inequality that the p of x is greater than or equal to the greater than equal to 0, that means we want to consider all the portions of the graph where it is above the x-axis, above the x-axis. So that will be the picture, the color that we have there. These colors, the top above the x-axis. So it means that the intervals, okay, your intervals are basically from what? Your intervals are from -∞ to -2. That is 1. And then we have from -2 to -1. That's another interval. And then from -1 to 0.5. Okay. And then also 0.5 to 2. And then we have for 2 to positive infinity. Okay, 2 to positive infinity. So you see that these portions, the first one that satisfy the inequality is above, is greater, and then also between -1 and then 1 and 0.5, this also satisfy the inequality, and then also 2 to positive infinity. Now, because the inequality is greater than or equal to, what would be the solution of this? Okay, the solution will basically be, let me change my color. The solution will be from, the solution set will be from negative infinity to negative 2, all right? But you notice that because it's greater than or equal to, they will have brackets on the what? On the negative 2. And then also, that is union. We have it from what? 1, negative 1 to positive 0.45, actually. So that will be from negative 1 to 0.5, okay, union. And then also from 2, brackets on the 2 to what? Positive what? Infinity. Okay, so from this graph, if you want to solve that inequality, this will be what? This will be your solution. Okay, and if it's just if you want to find the probability, the polynomial, it's just less than 0. Okay, below the x-axis, excluding what? The zeros. So the solution to that, okay, the solution will be what? From negative infinity, negative 2 to negative 1. Okay, we got parentheses on that, and also from 0.5 to 0.5 to 2. Okay, so that will be the solution for this what? Inequality below the x-axis. Now we have this example that we started off doing in class. Now let's start it all over again. It's similar to your homework questions number 3 and 4. It says solve the inequality. Okay, now we're going to go through all the 5 steps that we talked about. Now, first is that you move all terms to one side. Okay, all the terms to one side. So it means that we move this to the what? The left-hand side. And then when we rearrange, you have 2x cubed plus x squared minus 13x plus 6 greater than or equal to 0. Okay, so the left-hand side, this part is your polynomial p of x that we have here. Okay, so now the next step is that we need to factor this. Okay, so how do we factor this? Well, if you go back and we want to factor this using the, let's say by grouping, because this is what? 4 terms as we did in class. You notice that it is not possible. This will be x squared. Okay, you have for x squared in parentheses, that is x plus 1. And then you have minus 1, and then you have 13 minus 6. All right, of course, then 13x minus 6 is not the same as x plus 1. So by grouping will not work. Okay, by grouping doesn't work. You cannot do this by what? By grouping. Okay, so then let's go to the way to do the alternative is that you can graph this, and then when you graph it, you can read the zeros, real zeros from what? The graph. If you are lucky, if they doesn't have, some of them are imaginary roots, then of course you have to look for just one of the zeros and then use a synthetic or division to find the other factors and get the zeros from there. Okay, so I did a graph, and as you can see, the graph, these are the zeros of what? Of the polynomial. All right, the graphs of the zeros of the polynomial. These are all real zeros, so that's a good thing, right? So from this, we have negative 2, so negative 3, okay? You have 0.5, that is 1/2, and then you also have, you have 2. So the zeros are negative 3, 1/2, and 2. So that means you have x is equal to negative 3, therefore x plus 3 is a factor. And then for the other 0, x, okay, is equal to 1/2. Okay, now multiply by 2, it gives you a 2x is equal to 1. And therefore 2x minus 1 becomes what? Becomes a factor. And then the last but not least, you have x is equal to 2. Therefore x minus 2 is what? Is a factor. Then when you multiply all of them, you get that. So either you can read these zeros and get your factors from the graph, or just use one of the zeros and find the other. So for example, if I use the 0, that is x equal to 2 is a 0, which means that x minus 2 is a what? It's a factor. All right. That is a factor. Okay. Then we can use the syntactic division to find the what? The other factors. Not knowing that it's going back, this is the polynomial function, right? So we have our polynomial function, which is what? 2x cubed plus x squared minus 13x plus what? Plus 6. Now, if I use a synthetic, right? Okay, my c is 2, and then I have the coefficients will be 2, 1, negative 13, and then 6. So we draw a line and drop the 2. 2 times 2 is 4. 4 plus 1 is 5. And then 5 times 2 is 10. And then negative 13 plus 10 is negative 3. Negative 3 times 2 is negative 6. 6 plus 6 minus 6 is what? Is 0. Okay, so then your coefficient, you have the factors will be x minus 3, so x minus 2 times 2x squared plus 5x minus 3. Okay, that is the polynomial. So this polynomial here is actually equal to that. So the question is that we need to factor the others, and if you factor, you have minus 2. All right. And then you have, if you put the 2x and then x, 2 times x is what? 2x squared, which gives me this one, this term right there. And then two factors of negative 3, that when you put them here and then multiply that, you get what? Minus positive 5x. And these factors will be what? Minus 1, x minus 1, and then plus what? Plus 3. So that gives us what? This probably in the polynomial factors factored into that, and that is it. Okay, so from this we get our zeros, negative 3, 1/2, and then what? 2. Also, you can read it from what? From the graph. All right, so now we have to find the intervals. Since you have the zeros, all right, negative 3, it means that from negative 3 to, so negative infinity to negative 3 is one of the intervals. Then from negative 3 to 1/2, which is the second one, then 1/2 to 2 is the third one, and then 2 to what? Positive infinity. So if you have this on the number line, right, you have negative 3. Okay, let's say 0 here. You have negative positive 1/2. You get 2, and then what? To positive infinity. So you give us these intervals. Now, once we have these intervals, we can determine go to step 4, where we find the table of the diagrams that we have. So we make a table or a diagram. Now, this table is different. I've updated the PowerPoint, so please make sure you have the most current one. So the intervals are put here. Okay, we have these columns for the intervals: negative infinity to negative 3, negative 3 to 1/2, 1/2 to 2, and 2 to positive infinity. Then the factors we have, remember, it's minus x minus 2 times 2x minus 1, and then x plus what? Plus 3. And this is greater than or equal to 0. So we put all those factors, the first one, the second factor, and then the third factor, and then the product of the 3. We want to look at the sign of this by picking test values in each of these intervals. So if I use minus 4 for that, okay, for that interval, let me change the color to say red. So if I use minus 4, and then for this interval, if I use 0, and for that interval, if I use, say, 1, and then this interval, if I use, say, 3. Okay, so we want to test this on each of the factors. Well, negative 4 minus negative 2, negative 4 minus 2 is negative. Okay, 2 times negative 4, which is negative 8, minus 1 is negative 9, which is also negative. And then negative 4 plus 3 you get -1, which is negative. So when you multiply these together, negative times negative is positive, and then times negative is negative. Okay, so let me use a different color. So this is what? This is negative, not positive. It's negative. Okay, that is negative right there. All right, then we go to the second interval. If it's 0, 0 minus 2 is minus, it's negative. Then 2 times 0 is 0, minus 1 is also negative. And then 0 plus 3 is what? Is positive. Okay, negative times negative is positive, times positive is what? Is positive. Okay, then we go to the third interval, pick 1. 1 minus 2 is negative. Okay, 2 times 1, which is 2, minus 1 is positive. And then 1 plus 3 is positive, 4. And then when you multiply this out, you have negative, positive times positive is positive, then times negative is what? It's negative. Okay. Then we go to the fourth one, right? The fourth one, where you have 3. 3 minus 2 is positive. Okay. 3 times 2 is 6, minus 1 is also positive. And then 3 plus 3 is 6, which is positive. Then positive times multiply themselves to get what? Positive. So look at our inequality. It's what? Greater than or equal to what? 0. So this product must be what? This must be what? Must be positive. Okay. So which of the intervals satisfy the what? The inequality. Okay. As you can see, it's going to be the second one, and then what? The fourth one. Okay. The second and the fourth. All right. The second and the fourth one. So we want to write our solution set. Okay. So we go to, we know that is what? From negative 3 to 1/2, and then 2 to positive infinity. But because it's what? Greater than or equal to, okay, there should be what? Brackets for the solution or the endpoints of these what? These intervals. Okay. Therefore, the endpoints, we see that -3, 1/2, and 2 satisfy the what? All the inequalities. So we go to what? Brackets, -3 to 1/2 bracket, and then or 2 to what? Positive infinity. Okay, so that gives us that solution to that inequality that we started off in class. All right, now we can grab this from the graph as I showed you earlier on. This actually confirms our solution. The portions that are above the what? Above the x-axis. All right, now let's look at the domain. Domain of this function f of x, which is 1 over the square root of x to the 4th minus 65x squared plus what? 64. Okay, now notice that this is a domain. We don't want, it's a rational function. We do not want the what do you call it? The denominator to be 0. We cannot have the denominator to be 0. So to be able to solve this, all right, we must, to find the domain, we must solve the inequality. Okay, for the domain, right? Okay, you must solve the inequality. Inequality is x to the 4th minus 65x to the 2nd plus 64 should be what? Greater than what? 0. We cannot include what? 0. It should be greater than 0. All right, so then we have to factor going through all the steps that we have. Now, step 1, it said that move all to one side. It's already done. Okay, that's already done. It's already done because all the terms are on one side of the inequality. What about step 2? We got to factor. Okay, that's where we have some work to do. So we pick what? X to the 4 minus 65x to the 2nd Okay, then plus what? 64. Okay, we want to factor this inequality. Okay, so we put a 2 back. Well, this is quadratic in what? X squared. Quadratic in S squared. So the coefficient of the leading term is 1. So we can do it as if we have what? It's in terms of x squared. So we put x squared here and s squared. So that s squared times s squared is what? X to the 4th, right? Then we want 2 factors of 64, all right? When we add, we get what? 65. Of course, we can have 8 and 8 and 8, 64, but when you add them, you don't get you get 16 by 165. So that is minus 1 and then negative 464. If you multiply, you get positive 64. When you add, you get what? Negative 65. So we put minus 1 and then minus 64. Okay, this is greater than 0. Now, each of these is the difference of squares. S squared plus minus 1, that's the difference of squares. S squared minus 64 is also difference of squares. So we're going to write this as what? X plus 1, x minus 1, and then we have x plus what? 8, x minus 8, okay, greater than 0. All right, so we factor this and then into that. So what are our zeros? Okay, the zeros are, in this case, the same. We call them later like cut points, which is the same. The zeros from each of these factors are, we have minus 8 from x plus 8. We have minus 1 from x plus 1. And then we have a positive 1 and then positive 8. All right. So if we have these, then what are our intervals? Okay, what are the intervals? Let's go to the next slide. That will be step 3. Step 3 will be the intervals. Okay, the intervals for each of these. We have it from negative infinity to negative 8, that is 1. From negative 8 to negative 1, that's the second one. Negative 1 to 1. And then 1 to positive 8, and then 8 to positive infinity. So this gives us these intervals, and then we want to know which of these intervals satisfy the inequality where the polynomial was greater than what? Is greater than 0. Okay, so we go to step 4, which is our table, right? So we're going to have this table, okay, where we write the sign of, okay, we have x plus x plus let's say plus 1, x minus 1, x plus 8, x minus 8. And then we have the product of all these, okay, x plus 1 times x minus 1, x plus 8, and then x minus 8. Okay, then we have the interval from negative infinity to negative 8, that is 1 interval. We have negative 8 to negative 1, that's the second one. We have negative 1 to 1, that's the third one. Okay, and we have 1 to what? Positive 8, that's the fourth. And then from 8 to what? Positive infinity. So we're going to test all these and then decide which intervals will satisfy the what? The inequality that we have. Okay, so let's pick some test values there. For this one, we will use negative 9. That we will use say negative say 4, which is there. Here we can use 0. Here we can use 4, and there you can use 9. So these are our test values. Let's test on each of them. Okay, negative 9 minus plus 1, that is be negative. So this is negative, that will be negative, that is negative, and that will also be negative. Okay, so negative times negative, positive, negative times negative is positive, so this is positive. Now let's go to the second one, negative 4. This will be negative, that will be negative, this will be positive, the third one, and that also will be what? Be negative. So positive, and that is, this gives me negative. Okay, then if you use 0, this, the first one is positive, the second one, 0 minus that is negative, the third is positive, and that is so negative. And then you have positive times positive is positive, and negative times negative is positive, so that is positive. And then we have 4, this is positive, that is also positive, this is positive, and that is also, this will be negative. And that makes it what? Everything negative. We multiply these together. And then finally, last but not least, if it's 9, 9 plus 1 is positive, 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 positive. So if you multiply, you also get positive. So if you want to find greater than 0, which of the intervals satisfy the inequality? Okay, which of the intervals? It will be the first one, this, and also that. Okay, so then we want to know the interval that satisfy the inequality are, okay, the intervals are from negative infinity to negative 8. We also have from what? Negative 1 to 1. And then we have it from what? Positive 8 to negative positive what? Infinity. All right. So then, now notice that, let's go back. It must be greater than, okay? These zeros are all, and none of them could be, can we include 1? Okay. If you go back to our original question, can we include any of these? If you put negative 1, okay, we have this, remember you have the f of x, right, was 1 over, if I've put the factors there, all the factors there, you have for x plus 1, x minus 1, x plus 8, x minus 8. Okay, now if we include any of this, if x is negative 1, the denominator will be what? Undefined. If x is positive 1, the denominator will be undefined. X is negative, is positive 8, okay, the denominator is undefined. So makes it 0, so the function is undefined. Therefore, we cannot include, all right, it should be, even though he said, even this is says being greater, don't even have to ask yourself like that question. It cannot include any of this. Therefore, the solution is actually what? Everything that we got there, because we don't have, it will be from negative infinity to negative 8, union minus 1 to 1, union 8 to positive infinity. So 8 to positive infinity. All right. So that gives us the solution to that. So this is your domain. Okay, this is a domain of the function f of x. That's the domain of the function f of x. All right. So that is the end of the part 1, and I will do the part 2 on what rational inequalities in a minute.